Hello everyone. Today I'll be taking the next topic for the course EE216 Electrical Engineering for Applied Electronics and Instrumentation, and today's topic is stepper motor. Actually this is my 10th lecture of the series. Myself Jayasree R Nair, and I belong to a Department of Electrical and Electronics Engineering of Rajagiri School of Engineering and Technology. Actually, my stepper motor topic is divided into 3 lectures. The first one, today I'll be taking the first one, and here I'll be covering what is a stepper motor, its characteristic features, some parameters related to stepper motors like step angle, resolution, rotor speed, applications of stepper motors, followed by advantages and disadvantages. Now, what is a step motor? Or stepping motor or stepper motor, and similar to any motors, it's a electromechanical energy converting device. Stepper motor rotates through a fixed angular steps in response to input current pulse received by its controller. And what do you mean by step? Step is defined as the angular position in degrees of the rotor each time it receives the pulse. Now, where can you find stepper motors? Stepper motors are extensively seen in timing devices, process control applications, 3D printers, robotics, etc. etc. We'll be studying in detail in further slides. Now, unlike other motors, here you don't have continuous energy conversion. No continuous energy conversion, as the rotor does not rotate continuously. Can be controlled directly by computers, microprocessors, or even programmable controllers. Position can be known simply by maintaining the track of input pulses, generally of low speed and low power devices. Now, they generally work in conjunction with electronic switching devices. Same switches the control windings of the stepper motor with a frequency and sequence corresponding to the command issued. When a definite number of pulses are supplied, shaft turns through a definite known angle. The sequence of the input pulse given to the stator determines the direction of the rotor shaft. Now, provides precise control in an open loop system. What do you mean by an open loop system? Without any feedback information about its rotor position. Speed of the rotor is determined by the frequency of input pulse given to a stator. We'll see the expressions later on. And to obtain high speed, feedback is generally employed. Position feedback is generally employed, not to lose steps. So this is the introduction about the stepper motors. Now we'll see the characteristic features, very much relevant to stepper motors. Can develop torque ranging from 1 micronewton meter to 40 newton meter. Power output ranges from about 1 watt to a maximum of 2500 watts. The only moving part is rotor, which has no windings, commutator or brushes. This feature makes it quite robust and reliable. Designed to operate for long periods with the rotor held in a fixed position and with rated current flowing through the stator winding. Now we'll see some parameters, the important parameters relevant to stepper motors, and the most important one is the step angle, generally designated as beta. And what's a step angle? The angle through which the motor shaft rotates for each command pulse. Smaller the step angle, greater the number of steps required per revolution and higher the accuracy of positioning required. Step angles can be as small as 0.72 degrees or as large as even 90 degree. And the common step sizes 1.8 degree, 2.5 degree, 7.5 degree and 15 and even 30 degrees also available. 15 degree, 30 degree, etc. Now we'll see the expression for step angle. Actually there are 2 expressions. Based on stator poles and rotor poles, we are having beta, which denotes the step angle, which is equal to ns minus nr divided by ns into nr into 360. Based on the number of stator phases and rotor poles, beta is equal to 360 divided by M into NR, where M stands for the number of stator phases, and what is stator phase will come across it, and the number of rotor poles designated as NR. Now what is a phase? Multiple coils of the stator that are organized in groups. Very important, multiple coils, we'll see it. Multiple coils of stator, which are organized in groups, semi-energized using current pulses. Now resolution, the second important parameter, very relevant to stepper motor. What is resolution? The number of steps needed to complete one revolution of the rotor shaft, given by the mathematical expression stands as 360 degrees divided by beta, where beta stands for the step angle, which I already seen in the previous slide. And the unit for resolution stands as steps per revolution. Higher the resolution, greater the accuracy of positioning of objects by the motor. Now, has the ability to operate at high stepping rates, even up to 20,000 steps per second, fully in synchronism with the command pulses. Command pulse rate high, shaft rotation beats continuous. That's an important aspect. If the command pulse rate is high, the shaft rotation seems to be continuous. Now we'll see the expression for shaft speed. The motor shaft speed designated as small n, not capital N, small n. Small n represents the unit is in revolutions per second. So small n represents beta into F divided by 360, where beta is the step angle and F stands for the stepping frequency of pulse rate in pulses per second, PPS. And the operation of step motor at higher speed, we have a term called slewing. What do you mean by slewing? Is an operation of stepper motor at very high speed. Now, if the motor is operating at very high speed, the motor can lose synchronism and stops if the stepping rate is increased too quickly, or if when the motor is slewing and the command pulses are suddenly stopped rather than progressively slowed. So, operation of stepper motor at high speed is called slewing, and the motor can lose synchronism and even come to standstill condition if the stepping rate is increased too quickly, or when the motor is slewing and the motor command pulses are suddenly stopped rather than progressively slowed. Now the very important thing, it has got extensive applications in various areas. So applications area wise we'll be discussing. First one, industrial application, process control, machine tools, extensively seen in packing machinery, robotics, pick and drop equipment, CNC. What do you mean by CNC? Computerized numerical control machines, IC fabrication, integrated circuits fabrication, textile industry, 3D printers, spacecraft. So these are the relevant areas in industry. Now coming to the medical applications, scanners, digital dental photography, fluid pumps, blood analysis machinery, and even found in respiratory machines. Now in automobile industry, air control valves, seen in air control valves, throttle motors, idle air control valves, wiper motors, office equipments, scanners, fax, photocopying machines, printers, timing devices like clocks, typewriters, and in electronics field, camera platforms, robotics, computer peripherals, graph plotters, and XY plotters. Now you can see another type of classification based on application. If you want to do position control, used for applications requiring precise position control such as 3D printers, office machines, X-ray machines, CNC machines, IC fabrication, textile industry, camera platform, XY plotters, etc. If you want to do some speed control, applications requiring precise speed control such as process automation, robotics, etc. Now, low speed torque applications, stepper motors have the ability to produce high torque at low speed, minimizing vibration, ideal for applications require quick positioning over a short distance. Now, incremental motion applications requiring incremental motion, such as timing devices, clocks, typewriters, printers, floppy disk drives, etc. Now, you can see the advantages behind the stepper motors. Several advantages are there. Provides a wide range of rotational speeds, rapid response to start, stop and reverse, can operate at full torque even at standstill, provides high accuracy in position control. Because of the absence of brushes, very reliable, generally uses open loop control, hence it is simple in construction and less costly. Now, some disadvantages are there for stepper motors. Draws more current when compared to DC motor of the same capacity. Torque decreases with increase in speed. Comparatively lesser efficiency than DC motor. Control is difficult at higher speed. Does not have integral feedback for position control. Requires micro stepping for smaller step angles. We will be discussing what micro stepping is in the next lecture. So these are some of the disadvantages. And the reference books onto which I have referred, AC and DC Machines Volume 2 by B.L. Thereja and A.K. Thereja, Theory and Performance of Electrical Machines by J.B. Gupta. Thank you.